You've probably heard the word black hole a bunch of times, right? It sounds like something from a sci-fi movie, a space monster that eats planets. In this video, let's make it super simple. I'm going to explain what a black hole is as if we were just chatting with a friend. No scary formulas, no super complicated words, just clear ideas, easy examples, and cool space images. By the end, you'll be able to explain to other people what a black hole is, how it's born, what parts it has, what happens if you get too close, and why scientists love them so much. So open your eyes wide, because we're going to the craziest place in the universe. Let's start from zero. What is a black hole, really? Forget the classic drawing of a hole in the floor. A black hole is a huge amount of stuff, of matter, squeezed into a tiny, tiny space. Because all that mass is squashed so much, gravity there becomes super strong. Gravity is the force that keeps your feet on the ground and makes things fall when you drop them. On Earth we feel it, but it's not too crazy. Near a black hole, gravity is so strong that if something gets too close, it can't escape. Not a rock, not a planet, not a spaceship, not even light. That's why it is called black. If light can get out, it looks totally dark from the outside, with bright stuff spinning around it. So a short definition would be, a black hole is a perfect gravity trap. Okay, how do you build something this wild? Most black holes we know start as giant stars that die. At the same time, gravity is trying to pull everything inward. As long as the star still has fuel in its center, those two forces are in balance. But one day, the fuel runs out, the push outward stops, and gravity wins. The star collapses, like a building when you knock away its columns. In some cases, this ends with a gigantic explosion called a supernova. For a few days, that one star can shine brighter than its whole galaxy. What's left in the center keeps getting squeezed and squeezed. If the original star was big enough, the core can't stop collapsing and turns into a black hole. So, quick recipe. Very big star plus no more fuel plus total collapse equals a black hole. Now that we have the monster, let's open it up a bit and name the main parts. First, the event horizon. Imagine you're in a small boat going toward a giant waterfall. There is a point where, even if you row as hard as you can, the current is too strong and you can't go back. That too late now line is like the event horizon. It's an invisible border around the black hole. If something crosses that border, there is no way back. Not even for light. Next, the accretion disk. That's the stuff that is falling in but hasn't crossed the border yet. Gas, dust, pieces of stars, all spinning and heating up like crazy. It gets so hot that it shines brighter than millions of stars together. This is the spot where, in our math, all the mass of the black hole is squeezed into almost zero size. That sounds weird because our normal physics doesn't really work there. It's like the rules of the game break. We know something is there, but we don't yet know exactly how to describe it. It's one of the biggest open mysteries in science. Time for the scary part everyone asks about. What happens if a person gets too close to a black hole? Far away, it would just look like another object in space, maybe with a bright ring around it. But as you move closer, things get rough. Gravity near a black hole is not the same everywhere. But for someone far away watching you, it would look like you slow down as you approach the event horizon. If the sun suddenly turned into a black hole, with the same mass, Earth would keep going around it almost the same way. We'd lose the light and heat, so life would be gone. But the orbit would be almost the same. Then there are supermassive black holes. These are the big bosses of the universe. They sit in the center of almost every galaxy we know, including our own Milky Way. They can have millions or even billions of times the mass of the sun. They are so huge that the motion of many stars around them is controlled by their gravity. The one in the middle of our galaxy is called Sagittarius A star. And even though it's very far away, it acts like the heavy anchor of the Milky Way. Scientists also think there might be intermediate black holes, with hundreds or thousands of solar masses, but those are harder to find and still under study. And some theories talk about tiny, microscopic black holes that might have formed right after the Big Bang, but those are still just ideas on paper. All this sounds cool, but you might say, okay, but if light can't escape, how do you know black holes are really there? Great question. Astronomers act like detectives. They don't look at the black hole directly. They watch what happens around it. If they see a star whipping around an empty point in space going super fast, they can calculate that there must be something very massive in the middle pulling on it. They also watch the gas and dust that are falling in. As that material spins and gets closer, it gets squeezed and heated so much that it gives off X-rays and other kinds of radiation. We can detect that with special telescopes. Ayam! In 2019, something historic happened. We got the first image of the edge of a black hole in the galaxy M87. It doesn't look like a perfect hole. It looks like a bright orange ring with a dark center. That dark area is the shadow of the black hole, the place where light can't escape. To make that picture, scientists combined data from radio telescopes all over the world, like turning Earth into one giant telescope. A few years later, they did something similar with Sagittarius A star, the black hole in the middle of our own galaxy. If that's not enough proof for you, there's more. Gravitational waves. Imagine space-time is like a stretchy rubber sheet. If you put a heavy ball on it, the sheet bends. If you crash two very heavy balls together, the sheet wiggles and sends out ripples. That's kind of what happens when two black holes orbit each other, then crash and join into one. In 2015, giant detectors called LIGO and Virgo felt those tiny wiggles in space-time for the first time. The changes were insanely small, smaller than the size of a proton, but still real. When scientists looked at the data, they saw it matched perfectly with two black holes colliding billions of light years away. Since then, many more signals like that have been found. Each one is like hearing a distant boom from black holes merging. It's literally like listening to the universe's heartbeat. After all this, it's normal to think, wait, is a black hole going to come and eat Earth? Good news, nope. They are objects with gravity, just like stars and planets. Because black holes are perfect places to test our best ideas about the universe. We also think supermassive black holes help shape galaxies and help decide how matter is spread out across the universe.